Welcome. Let's take a look at some examples where we can use the proportions of special right triangles. Let's understand the scenario that we have here. We have a right triangle, and then in addition, we have the altitude of that right triangle. And this altitude, it creates three right triangles. And when we have this scenario, we can use the proportions of special right triangles. Let's start by identifying the unknown. In this case, the unknown x is the length of that altitude. But remember that the altitude, we can think about it as a geometric mean. A geometric mean between the line segment AD and DC. Which notice that that's the same scenario as we have in this example, where H can be seen as the location of x and AD can be seen as the length of 6, and DC can be seen as the length of 3. So now we can set this up. We can have 6 over x equal x over 3. And now that we have this scenario, to properly solve for x, let's cross multiply. We'll have x squared. Now let's multiply 6 and 3, which is going to give us 18. To solve for x, let's take the square root. That way the second degree is going to cancel out. And now we have that x is equal to plus or minus square root of 18. But even though we have a plus or minus, notice that x is a length, so we cannot consider the minus sign. So now we know that x is just going to be the positive square root of 18. So even though we have found the value of x, we can simplify the square root of 18. Notice that 18, we can write it as 9 times 2. And by the rule of roots, we can write this down as square root of 9 times the square root of 2. But we do know what's the square root of 9. The square root of 9 is 3. So we have our final conclusion. Now we can say that x is 3 square root of 2. Let's take a look at another example. Notice that we have the same scenario. We have a right triangle, and then we are introducing an altitude. And because of this scenario, we have 3 similar right triangles. Then we can use the proportions of similar right triangles. Let's identify the location of the unknown. The unknown can be seen here as y. That is one of the legs of the right triangle. But remember that the leg of the right triangle, we can think about it as a geometric mean. And that is a geometric mean between the line segment AD and AC. So now let's plug in the values in our problem to the proportion that we know is true, where in this case, the value of the length is the unknown y, the value of AD, that will be 2, and the value of AC is the addition of 2 plus 5, which is 7. So now let's set this up. We have 2 over y, and that is equal to y over 7. Let's solve for y by cross multiplying. That will be y squared. And 7 times 2, that is 14. To solve for y, let's take the square root. Now the second degree cancels out. And now we have that y is equal to plus or minus square root of 14. But remember what y stands for. Y is length. There is no such thing as a negative length, but we do not consider the minus part. We cannot simplify the square root of 14, but we have our final answer. Let's take a look at another example. Notice that we have the same situation. We have a right triangle, and within the right triangle, we have an altitude. And that altitude created 3 right triangles, therefore, we can use the similarity right triangles proportion. Let's identify the location of the variable. The variable can be seen as the length of the altitude of this right triangle. But remember that the altitude of that right triangle can be seen as geometric mean. A geometric mean between AD and DC. But notice that we encounter a problem because the altitude of the right triangle, which in this case is x, if we plug it into our proportion, we do not know what's the length of AD, and we do not know what's the length of DC. So essentially, before we can use this proportion, we need to either know what's the length of one of those two. Now let's think about how we can get one of those two lengths. Notice that within this problem, we are given 12 as the length of one of the legs and 16 as the length of the second leg. But remember that we also have a proportion for one of the legs of the right triangle. That length can be seen as a geometric mean in relation to the length of AD and AC. But in this problem, AD is one of the legs that we are missing, and AC is the whole hypotenuse. So let's call this question mark. And now let's plug it in to our proportion. The length of AD is what we're looking for. Let's keep it as a question mark. The length of the first leg is 12. We can put it on the denominator and the numerator. And the length of AC, it is 20. Notice there's only one unknown. We can solve for it. If we cross multiply, that is 144. And if we cross multiply, that is going to be 20 times the question mark, which we're looking for. Notice that that's a multiplication, so let's get rid of the 20 by dividing. So now we know that the value of the question mark, it is a 7.2. Let's put that down in our diagram. So if the whole hypotenuse has a length of 20, and this section has a length of 7.2, then this section that we were looking for would be equivalent to 20 minus 7.2, which is equal to 12.8. Now that we have this extra information, now we can go back to the proportion that we had originally for the altitude of this triangle. Let's remind ourselves what's that proportion. The altitude of a right triangle, it is a geometric mean between the line segments AD and DC. And now notice that the altitude, it is what we're looking for, and AD can be seen as 7.2 and DC can be seen as 12.8. So now let's just plug in these values in our proportion. The altitude is x, and the numerator of AD is 7.2, and the denominator of DC is 12.8. And now that we have this scenario, let's cross multiply. X times x is x squared. And 7.2 times 12.8, that is equal to 92.16. To solve for x, let's take the square root. So now we can say that x is equal to the square root of 92.16. We can simplify our result because the square root of 92.16, it is equal to 9.6.
Hello, if you would like to continue learning about mathematics, you can check out the videos on the left.